Hello friends, in this session we are going to see some advanced question from quadratic equation. So for those advanced questions, we require one or two more concepts based on the quadratic equation. So let's quickly see the concepts first, and then we'll see different type of questions that they have started asking in different banking exams, apart from the ones we already have seen, like the root comparison based questions. So this class will be about only the advanced questions, the different type of questions than the ones we have seen. So the concept that we require here is basically general form of quadratic equation is given as ax square plus bx plus c is equal to 0. This we call as the general form of quadratic equation. Now based on this form, if the roots are alpha and beta, then one of the root alpha is given as minus b plus under root b square minus 4ac upon 2a, and beta is given as minus b minus under root of b square minus 4ac upon 2a. If you add these two, that becomes alpha plus beta, that is sum of the root minus b upon a. And if you multiply these two, alpha into beta, the product of the root, it becomes c upon a. This formula is called as Sridharacharya formula, with the help of which we can find the roots of the given quadratic equation. Now, this part here, inside the root, which is b square minus 4ac, is also called as the discriminant or delta. Now, that discriminant tell you about your nature of your roots. So if the value inside the root, if that becomes a negative, that means if delta is negative, so inside the root, if you put a negative value, that makes that as a complex number, and hence the roots will be complex. Roots are complex or imaginary. The roots will be imaginary. And those will be complex conjugate of each other. Imaginary means complex. Conjugate. Now, what do you mean by conjugate? Conjugate means if one of the root, for example, if one of the root is 3 plus I, so another root will be 3 minus I. These are called as the complex conjugate. That means they exist in pair. The general form will be if one of the root is a plus ib, the another root will be a minus I. This type of pair is called as complex conjugate. So if you are given one of the root, then another root you can find, because they will be complex conjugate of each other. But what if the number inside the root that becomes 0? That means if delta is 0, if delta becomes 0, so that means whatever the inside bracket, that also becomes 0. So whatever after this plus or minus, it's 0. So that makes both the roots as equal. So then we say the roots are real and equal. Both the roots will be equal. And lastly, if whatever inside the under root, if that is a positive quantity, that means if delta is positive, then the roots are real and different. Then we'll have proper two roots. Those will be different and real. Also, one more statement you can put, that whatever the inside the root, if that is a perfect square, that means if whatever inside root, that is if delta is perfect square, so that will remove the square root, because if you put, let's say, perfect square inside the root, let's say root 36, so that will bring out as 6. So that if bring out the part of the root, that means it is not a surd now. So that makes that as a rational number. So roots will be rational. Roots are rational. So when the roots become rational, when whatever the inside the root, if that is a perfect square, that means if delta is perfect square, then roots are rational. So we can state that. So there are questions asked based on this sometimes, where one of the number will be hidden and given in terms of k, and they might ask you for what values of k this quadratic equation has equal roots or imaginary roots, etc., etc. So different type of questions can be asked in these exams. So you should know these three basic rules, and along with this sub rule, we can say. Okay. And one more concept we need to understand, that is factors theorem. We call as the factor theorem. What do you mean by factor theorem? See, let's take an example. Let me write a quadratic equation x square minus 5x plus 6 is equal to 0. Consider this is a quadratic equation. So if you want to find the roots of the quadratic equation, what we do is we do the factorization. You break the middle term such that the product is 6. So you know the numbers are -2 and -3. So you break the middle term, x square minus 2x minus 3x plus 6 is equal to 0. Then from the first part, you take x common. So what remains inside the bracket is x minus 2. From the second part, you take -3 common. So what remains inside the bracket is x minus 2. And then from this side and this side, we take x minus 2 common. So what remains inside the bracket is x minus 3. That means this expression can be written as product of these two. So if it was a number which we can write as a product of two numbers, so these two called as the factor of the bigger number, right? We call these two as the factor, because for example, 36 is a number. 36 if we write as 9 into 4, so we call 9 and 4 as factors of 36. So similarly, these two are factors of this. If you divide 36 by 9, we get 4. That means if you divide this expression by one of the factor, another factor can be calculated. So if you divide 36 by 9, if you get 4, that means if you divide this expression by one of this, you get the other factor. Okay, so we use that in certain question. And now the final part about this factorization or factor theorem is, you know, if you put this is equal to 0, we get x is equal to 2. And if we put this is equal to 0, we get x is equal to 3. And those are the roots. And what are the roots of quadratic equation? Roots are those numbers which, if you replace x with, the value of the quadratic expression becomes 0. That means if you put x is equal to 2 here, we get 0. That is 2 square means 4. Putting x is equal to 2, we get 2 square, that is 4, minus 5 into 2, that is 10, plus 6. So we get 0. Or if you put x is equal to 3, then it becomes 3 square, that is 9, minus 15 plus 6, that also will be 0. So roots are those values of x for which the quadratic equation actually becomes equal to 0. This expression actually becomes equal to 0. What that means is, if x is equal to 2 is root, x is equal to 2 is root, that means x minus 2 is factor. X minus 2 is factor. And similarly, if x is equal to 3 is the root, that means taking that 3 this side, it becomes x minus 3, and that is the factor. So x minus 3 is the factor. This is called as factor theorem. So if you want to figure out whether this is factor of the quadratic expression or not, whether x minus 3 is the factor of this quadratic expression or not, so what you have to do is, you have to put x minus 3 is equal to 0. That gets x is equal to 3. If that x is equal to 3 satisfies this equation, that means if you put x is equal to 3, if that becomes 0, then x minus 3 is the factor. X is equal to 3 is the root, and x minus 3 is the factor. This bracket is the factor. Got this? Okay, so this is theory wise, we are done. let us see now different type of question. Every question will have its own type. So we can only learn better with questions for different type of questions now. So let's start with question number 1. Now this is the question which says alpha and beta are the roots of the equation x square minus 5x plus 6. Then what is the value of alpha plus beta? Because we have learned how to calculate or how to solve for the roots easily, we can solve this question calculating roots as well. What we do is we break the middle term such that the product is 6. So you can break it as -2 -3. And you change the signs. So those becomes +2 and +3. So those are the roots basically. The roots are +2 and +3. And they are asking what is the value of alpha plus beta. That is the sum of the root. 2 + 3 is 5. So sum of roots will be 5. But we just saw there is another way to calculate sum of roots, and that is you have to first map the given equation with the general form of the quadratic equation, that is ax square plus bx plus c is equal to 0. You have to map this equation x square minus 5x plus 6 is equal to 0. So whatever in front of x square is 1, so we say a is equal to 1. Whatever in front of x is -5, so we say b is equal to -5 and c will be equal to the constant, that is 6. Sum of the roots is given as -b upon a. Minus b means minus of -5 upon a is 1. So that becomes +5. So sum of roots is +5. So you should be able to solve these type of questions now with the help of this formula here and not like this, because sometimes it might happen that calculation of root might not be very easy. If you are asked only sum of the roots, that is a better approach or better way to solve. Easy. Let's see one more question. They're asking one of the factors of this quadratic expression is. So we just saw the factor theorem. So what factor theorem states is, if you need to check whether these numbers are factor or not, let us start with option number 1. So you have to put that is equal to 0. That will get us a is equal to 6. So if a is equal to 6 is the root of this expression or this quadratic equation, then a minus 6 will be factor. How to check whether this is root or not? You have to put a is equal to 6 here and check whether that gets 0 or not. So putting a is equal to 6 here, we get a square means 36 minus 4 into a, that is 4 into 6, 24 minus 12. Is this 0? Yes. 36 minus 36, that will make it 0. So a is equal to 6 is the root of this quadratic equation, and hence a minus 6 is the factor of this quadratic equation. Let us try option number 2. If you put a is plus 6 is equal to 0, that gets us a is equal to minus 6. So by putting a is equal to minus 6, we get minus 6 square, that is 36. Minus 4 into minus 6, that is plus 24 and minus 12. Is this 0? No, that is not equal to 0. So this is not the root, and hence this is not the factor. Lastly, if we need to check the third one, of course, if first one is the answer, we don't need to, but we just as a practice, we are doing this. A minus 3 is equal to 0. That gets us a is equal to 3. By putting a is equal to 3 in this quadratic equation, we get 3 square, that is 9, minus 4 into 3, that is 12, minus 12. That is not equal to 0. And hence, this is not the root, and hence this is not the factor. So I hope you understood how to use the factorization theorem, factor theorem, to solve these type of questions. Those are the typical questions from the factor theorem. Let's see one more. If the equation has equal roots, then what are the values of k? So we know when the equation has equal roots, when the discriminant, which is b square minus 4ac, if that becomes equal to 0, then the equation has equal roots. What is the discriminant here? 3 square. 3 square means 9. 9 square means 24. 24 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 square means 24. For that, you need to write the general form ax square plus bx plus c is equal to 0 and map. So here x square has coefficient 4. That means a is equal to 4. b is equal to minus 2k. b is equal to minus 2k. And c is equal to 3k. So putting these values here, the discriminant becomes b square means 2k's minus 2k's whole square. B square minus 4 into A into C. That is 4k square minus 4 into 4, 16 into 3, 48. 48k. That should be equal to 0. So if you take k common or 4k common for that matter, if you take 4k common, we are left with k minus 12. So either this is 0 or this is 0. Either this is 0 or this is 0. So once you put 4k is equal to 0, we'll get k is equal to 0. Once you put this is equal to 0, we'll get k is equal to 12. So two values of k are possible. One is 0, another is 12. And hence the answer will be option number 3, that is 0 and 12. Easy? Let's see one more. It says alpha and beta are roots of the quadratic equation. If alpha minus beta is 16 by 3, then find the value of p. So you know the value of a in the sense x square's coefficient, you know x's coefficient. So you can calculate for the sum of roots. So if the roots are alpha and beta, you know the sum of root alpha plus beta is minus b upon a. Here, if you map it, ax square plus bx plus c is equal to 0. The value of a will be 3. The value of b will be minus 20. And value of c is p. Sum of roots is minus b upon a. So minus of minus 20 upon 3. That gets us 20 upon 3. Sum of roots is 20 upon 3. So alpha plus beta, which is sum of roots, if that is 20 upon 3, and the difference of alpha and beta is given 16 upon 3, then you can calculate for alpha and beta, two equation, two variables. If you add these two, we get 2 times of alpha is equal to 20 plus 16, 36 upon 3. That is 12. So alpha will be equal to 6. If you put alpha is equal to 6 here, so beta will be equal to 20 by 3 minus 6. And hence beta will be equal to 2 by 3. So alpha is 6, beta is 2 by 3. They are asking what is the value of p. So p you can calculate by product of roots. You know product of roots is alpha into beta. This is product of roots c upon a. That is p upon 3. And that should be equal to product of roots alpha into beta, 6 into 2 by 3. That is 4. So p becomes 4 into 3, that is 12. So the value of p becomes 12. Easy? Let's see one more. It says, if alpha and beta are roots of the equation, then find the value of alpha square minus beta square. They are asking what is the value of alpha square minus beta square, knowing alpha is greater than beta. So we can use one quadratic equation here or algebraic equation, that is p plus q whole square. So you must be knowing what is p plus q whole square. P plus q whole square is p square plus q square plus 2pq. And p minus q whole square is p square plus q square minus 2pq. Right? Okay. And now what we can do is, if we subtract from both sides, or here if you add on both sides, no, we'll subtract from this side. So here if you subtract 4pq, and here also if you subtract 4pq, so what it gets us, p plus q whole square is equal to, that will be p square plus q square minus 2pq, which is p minus q whole square. So p minus q whole square, and this will go that side, add as plus 4pq. Why we are doing this? Because we have to calculate alpha square minus beta square. Or better, we can say p minus q will be equal to p plus q's whole square minus 4pq and the root of it. So if you have to calculate now alpha square minus beta square, which can be broken as alpha plus beta into alpha minus beta, So alpha plus beta is sum of roots. Sum of roots, you know, that is minus b upon a. Minus b upon a means 15 upon 1, or that is 15, into alpha minus beta. So you can just use this now. Alpha minus beta will be equal to under root of alpha plus beta whole square minus 4 times alpha beta. What is alpha plus beta? Alpha plus beta sum of roots, as we already seen, 15. And what is alpha beta? The product of roots. Product of roots is c upon a, that is 56. So alpha minus beta you can calculate under root of alpha plus beta whole square, that is 225, minus 4 times of 56. 4 times of 56 will be 224. So that becomes 1. So alpha minus beta is 1. So this product is 15 into 1, that is 15. The answer here will be 15. Can we solve this question directly solving for the roots? Yes, we can. Definitely. We have learned how to calculate the roots. How to calculate the roots here? You can just break the middle term such that the product is 56 and the numbers are going to be minus 7 minus 8. Minus 7 minus 8 is minus 56. Minus 7 into minus 7 minus 8 is minus 15. Minus 7 into minus 8 is plus 56. So the roots are plus 7 and plus 8. Fine. And their addition will be 7 plus 8, 15. Of course, we can do it like it. But as I said, every time it might not be the case that you can break the number easily. Sometimes the roots can be irrational as well. They can go into the surds. You then might have to use the Sridharacharya formula to solve for roots. This we can do easily because the number can be broken as a product 56. If it can't, then you'll have to use another method, which is Sridharacharya, and that is not a very easy method to go for. That's why you should know these things, how to manipulate between alpha plus beta and alpha minus beta. That means how to convert one into another. So what we do is we directly memorize this final result. If you want the subtraction of the roots, then it will be under root of addition square minus 4 times of product. So you can just memorize this end result. Don't have to derive this all the time. Got this? Okay, let's see one more. It says, if one of the roots of quadratic equation is 7, then find the value of k. This is easy question because if the last part is known, then we can go for the product of the root. So if one root is 7, another root, let's say, is beta. So 7 into beta, the product of the root is c upon a. C here is minus 42, a here is 1. So 7 into beta is minus 42. That gets us beta is equal to minus 6. Beta is equal to minus 6. They want the value of k. So sum of roots, that means alpha plus beta, that is 7 plus minus 6, sum of roots, which is 1. And that should be equal to b upon minus b upon a. So minus k upon 1 should be equal to 1. That makes k is equal to minus. That makes k is equal to minus 1. So the value of k is going to be minus 1. Easy? This is easy question. Let's see one more. Of course, there is another method to do it. I mean, once you realize the another root is minus 6, so you can form your own quadratic equation also. Because see, 7 is root and minus 6 is root. That means x minus 7 is the factor and x plus 6 is the another factor. So product of these two should be this expression. Just do the product. That will get us x square minus x plus 42 is equal to 0. And hence the value of k will be minus. I hope you got this. Why these are the factors? Because 7 if is the root. So x minus 7 is the factor. We learned that. And minus 6 if it is the roots. That means x minus minus 6 or x plus 6 is the factor. Okay? Fine. Let's see one more. It says if p and q are the roots of the equation, then what are the values of p and q? Basically, they're asking. Okay, let's see this. If p and q are the roots of the quadratic equation, then what are the values of p and q? So, you know, if p and q are the roots, so sum of the roots p plus q will be minus b upon a. So minus p upon 1 is the sum of roots. So if you rearrange it, it becomes q is equal to minus 2p. And the product of the roots, that is p into q, will be equal to c upon a. C upon a. A means 1. So that makes it q. If you can cancel like q like this, in this case you can. Like q and q you can cancel, but algebraically that is not a correct way. You have to get the q on this side. You have to write pq minus q is equal to 0. And then you have to take q common. P minus 1 is equal to 0. So either this will be 0 or this will be 0. So q is equal to 0 is also one of the option. And then p minus 1, if you put 0, that gets us p is equal to 1. So p is equal to 1 or q is equal to 0. Q is equal to 0 is also option. But now if you put q is equal to 0 here, p also becomes 0. And then the quadratic equation doesn't make any sense. If that is also 0, p is also 0, q is 0. So x square is equal to 0. That don't have any roots. So that is why we cannot put q is equal to 0. But otherwise, q is equal to 0 is also one of the solution for this equation. So you can't just cancel in algebra. You can't just cancel like this. You have to take everything on one side and then make equation out of it. So that means p is equal to 1 is now solution. If you put p is equal to 1 here, we get q is equal to minus 2. So p is equal to 1 and q is equal to minus 2. That is option number 1 is the answer. Option number 1 is the answer. Get this? Okay, let's see one more. Okay, this is an interesting question. If minus 1 is one of the roots of the polynomial, then what are the other two roots? First of all, they are asking roots of polynomial. So whatever we learned for roots as a quadratic equation, same applies with the polynomial. That means higher degree. Like here the degree is 3. So it will be applicable here as well. That means if these are the roots or whichever option is correct, both the value should satisfy in the sense when you put as x, that should give you 0. 0 as the answer. So that means you can go with the options as well. Just quickly pick one by one options. Start putting x is equal to 1. So if you put x is equal to 1, that is putting x is equal to 1. That gets us 1 cube 1 plus 5 into 1, 5 minus 1 minus 5. Is this 0? Yes, that is 0. That means x is equal to 1 is one of the root. So that means this cannot be the answer. This cannot be the answer. Now try putting x is equal to 5. If I put x is equal to 5, so 5 cube is 125 plus 5 into 5 square, that is again 5 cube, 125 minus 5 minus 5. Is that 0? No. That means x is equal to 5 is not the answer. So the answer can be, this also cannot be the answer. So answer only can be this. So x is equal to -5 should definitely satisfy this, and it does. It's right, because that will get cancelled with each other. So x is equal to -5 should definitely satisfy that. You can check on your own. But another way to do this type of questions could be, or they ask something else. They ask what is the sum of the other two roots. That is also can be solved by using sum of roots for polynomial. But we don't learn too much into that deep, this topic. So the best way here is put the options. But if the options are something else, or something else is asked, what is the difference between other two roots? If that had been asked, then we don't know the roots. We can't just put it here. For that, you have to have another method. So another method means what? As we discussed earlier, if this is expression and -1 is one of the root, so x minus -1, that is x plus 1, should be the factor of this. So as we discussed, 36 had two factors, 9 and 4. There are multiple factors of 36. We are just taking as example. When you divide 36 with 9, we get 4. That means if you divide this expression with one of its factor, x plus 1, you get the remaining factor. So how to divide? In school days, we learned one method, how to divide the given polynomial with another expression. So what we do is, we try first of all to get this x as x cube. So we have to multiply with square. So we write here x square. Now we multiply that x square with 1. Both basically. X square into x, we write here x cube. X square into 1, we write here x square. And then we subtract. So once we subtract, this x cube get cancelled. Now 5x square minus x square is 4x square. And then everything we just note down from the top, because basically there is nothing to subtract, means basically we subtract 0, 0 from this. So what remains is 4x square minus x minus 5. Now again, we try to make this x as 4x square. So we have to multiply here with 4x. So we write 4x. Now with that 4x, we again multiply both. So that gets us 4x square plus 4x. And then we subtract. So 4x square gets cancelled. What remains is 0. So minus x minus 4x, that is minus 5x minus 5. It's what remains. Now we try to get this x as minus 5x. So we multiply here with minus 5. And with this minus 5, we multiply both. So we get minus 5x minus 5. And then when we subtract, we are left with 0. That means this is the quotient. So when you divide this algebraic expression with the smaller one, we get this. That is another factor. So x square minus 4x plus 4x minus 5 is another factor. So whatever the roots of this are going to be the other two roots of this. Now, can you calculate for the roots of this? Yes, it is a quadratic equation. You know how to calculate the roots for this. All you have to do is you have to break the middle term such that the product is going to be minus 5. So you can write plus 5 minus 1. Plus 5 minus 1 is plus 4. Plus 5 into minus 1 is minus 5. Hence, the roots will be minus 5 and plus 1. So as you can see, the other two roots are minus 5 and plus 1. Easy? Then you'll have to go through all this. But in exam, chances of coming these type of questions is very low. Let's see one more. Ujakar and Keshav attempted solving a quadratic equation. Ujakar made a mistake in writing down the constant term. He ended up with the roots as 4 and 3. Keshav made a mistake in writing down the coefficient of x. He got the roots as 3 and 2. What will be exact of the original quadratic equation? So let's say the original quadratic equation is ax square plus bx plus c is equal to 0. The first person, he made a mistake in writing down the constant term. That means instead of c, he written down something else. So he written down that quadratic equation as ax square plus bx, but instead of c, he written something else. So we'll write c1. So for the first person, this is how the quadratic equation look like. For the second person, he wrote down the coefficient of x, wrong. So for him, the A will be same, the C will be same, but the B, he written down something else. So let's say he written down B as B1. Now, the first person, he got the roots as 4 and 3. And another person, he got the roots as 3 and 2. Of course, both made mistakes. So both roots are wrong. His roots are also wrong. His roots are also wrong. But because in actual equation and his equation, B and A are same. So whatever the sum of roots of this equation will be his sum, because here the sum will be minus B upon A. Here the sum will be minus B upon A, because B and A are same in both cases. So minus B upon A, both sides same. That means the sum of root will be same. So his sum of root is 7. So actual sum of root will also be 7. In his case, he written down the B wrong, but his C is correct. So his product will be correct because product is C upon A. So here the product is C upon A. Here also the product will be C upon A. That means whatever the product of the second person will be the actual product. So product of roots here is 3 into 2. That is 6. So the product of roots is going to be 3 into 2, means 6. So the actual roots are those whose sum is 7 and product is 6. So you can go with the options. So which option has a sum of two roots as 7 and product as 6? Option number A. 6 into 1 is 6, 6 plus 1 is 7. So sum is 7 and product is 6. Hence, answer is option number A. Easy. Or with this sum and product, you can make again your own quadratic equation and then solve. See, because we know the general form of quadratic equation is ax square plus bx plus c is equal to 0. So if you divide all the sides with a, all the terms with a, we are left with, when dividing by a, we are left with x square plus b upon ax plus c upon a is equal to 0. And now we know b upon a is minus b upon a is sum of roots. So b upon a will be minus of sum of roots. So we can say x square minus sum of roots into x plus c upon a is product of roots in plus product of roots. That should be equal to 0. So if you come across sum of roots and product of roots, you can form your own quadratic equation and then solve for its actual roots. So we know the sum of roots, we know the product of roots. We can thus find our own quadratic equation and then find the actual roots of that. Easy? Let's see one more question. The quadratic equation has two roots, 4a and 3a, where a is an integer. Which of the following is possible value of b square plus c? So you know, if the roots are 4a and 3a, the sum of roots, which is minus b upon a. So minus b upon a here is 1. So value of minus b is going to be 4a plus 3a, sum of root, which is 7a. We want b square. So minus b if 7a, b square, that means squaring both sides basically will be equal to 49a. B square will be equal to 49a square. So 49a square. Also we want c. For c we require product. So product here will be c upon a, which is 1. And that should be equal to product of this 4a into 3a, that is 12a square. So c is 12a square. They are asking what is the possible value of b square plus c. So b square plus c is 49a square plus 12a square, that is 61a square. So this is the possible value. This is the value of b square plus c, which is the possible value. So that means, first of all, 61a square where a is integer. That means a square number into 61 should be one of these numbers. So if you try dividing this number with 61, you should come up with a perfect square number. So if you try doing that, option D will satisfy because it's easily 549. If that becomes 61 a square will be, this is 9 times of it. So a square will be 9 and then a will be 3. So wherever you get answer as proper integer for a, that only can be the answer because it says so a is integer, right? So try dividing every option with 61 and try calculating square root of it. If it is not an integer, that is not an answer. Got this? Okay, let's see. I think one last question. No, 2 last questions. Consider the pair of the equations where x is greater than y. They're asking then what is x minus y? Interesting question. So what we can do here is we can just add both the equation. If you add both equation, that becomes x square plus y square. X square plus y square minus xy plus minus xy minus 2xy minus x plus y should be equal to 22 plus 34, 56. And if you rearrange it properly, you see this is x square plus y square minus 2xy means x minus y's whole square. Also, if you take minus common, x minus y is equal to 56. And then you can just put x minus y is equal to k and write in terms of quadratic equation. So that looks like k square minus k minus 56 is equal to 0. You just have to find the roots of this. So you have to break k such a way the product is 56. That means minus 8 plus 7. Minus 8 plus 7 is minus 1. Minus 8 into plus 7 is minus 56. So the roots are going to be plus 8 and minus 7. In our previous video, we have seen how to calculate the roots quickly. So please refer that. K cannot be negative value because it says k is x minus y. And if x is greater than y, that means k has to be the positive one. So that means the value of k is plus 8. That is x minus y is plus 8. Easy. Let's see one more question. Last question. Roots of the equation will be reciprocal to each other. What is the value of a? So you know, if roots are reciprocal, that means if one of the root is alpha, another root is going to be 1 by alpha. So what is the product of root in that case? Product of root says alpha into 1 minus alpha. Product of root is going to be 1. So that means c upon a should be equal to 1. So 6 upon a should be equal to 1. The value of a then going to be 6. That is easy question, very easy question. So answer is going to be 6 here. Easy. So friends, I hope you understood everything. So these are the advanced level question you need to practice before you go for the exams like RBI Grade B. And in some cases, SBIPO, especially mains questions. In mains, they started asking this different type of questions. In pre, they still ask the same quantity comparison type question. So for pre, you don't have to, but for mains, you have to prepare this question. So even if you do these many questions, should be sufficient for RBI Grade B exam. Because as we discussed in the previous video of quadratic equation as well, even if they ask the questions apart from other than what the other banking exams ask, but the questions are still simple. So if you know the concept, what is the product of root, what is the sum of roots, and today as we learned the discriminants, how the discriminant values will affect your nature of roots. So even if you understand that table, you can solve the questions very, very easily and conveniently. Thank you for watching video. Have a good day.